Hey guys, today we're going to be talking about electrical charge and how that applies to the atom. So, before you watch this video, I hope you've already gone through the PowerPoint and read a little bit about the three subatomic particles, the proton, the neutron, and the electron. Well, today we're going to talk a little bit about their charges. When we talk about charge, I really want you to understand what that means. Most of us have seen a battery before. On a battery, I don't know if you've noticed, but one side always has this plus sign. And just like in math, that plus sign means positive. And then on the opposite side, we have the negative sign. So batteries have a positive side and a negative side. And if you ever look inside of something that requires batteries, it'll tell you which side goes where. And that's because both sides are required to create a chemical reaction that causes an electrical current. So when we're talking about batteries having a positive and a negative side, we only know that because of the indications on the battery, the plus and the negative. Something else that you might know about that has a positive and a negative charge are magnets. Magnets, often you'll see that they can connect. That means that they're attracting each other. And then the opposite sides will repel, which means push apart. If you have magnets at home on your fridge or anywhere, you can grab them and try this as well. So when we're talking about positive and negative charges, we're really looking at the proton, which is the positive charge, and the electron, which is negative. Now, when we draw a triple bubble, you'll notice that the proton and the neutron are right next to each other, while the electron is slightly above. So the reason that is because when you have two things of like charge, like two positives, they will repel each other. Here I'm standing up the magnet, and you can see it's already wanting to be attracted to another magnet. The reason I have this notebook on the table is because my desk is actually made of metal, and so the magnets are attracted to the desk. So I set this notebook here to help get rid of some of that magnetic force. So if we have two magnets and we try to put them together on the same side, you can see without even touching, it's going to cause that magnet to move. And that magnet is going to try to join in to the other magnet on the side that is the opposite. So we'll do that again. If I stand up this magnet, this side here on the magnet is the same charge, positive or negative, as this side of the magnet. And so when I try to get this magnet close to the other, it's going to cause the first one to spin. And usually it'll cause it to spin and then find the opposite side. If you've ever heard the saying opposites attract, this is what we're talking about. You can tell that whenever you try to put like sides together, the magnet just doesn't want to do it. They don't want to come near each other, and what we call that is they repel. They push each other apart. You might have seen magnets like this. You can throw them and they make like a fun noise. These magnets do the same thing. If I set this magnet sideways and I try to find the side that is opposite of this magnet, you'll see the one on the ground start to spin and turn because it's trying to repel the like charge. And you can see I don't even have to get near it to cause it to move. If I do get near it with the same side, they attract each other. This is what an electrical charge is. We see it in magnets. Here's a really strong magnet. We see it in batteries. And we're going to be talking about it with our atom. So remember, if the charges are similar, if they're the same, positive and positive or negative and negative, they're going to repel each other. But if they're opposite, just like these magnets, they're going to attract.